Solving quadratics by factoring. In this part of the concept, we're going to focus on trinomials, which are quadratics with 3 terms. Okay, so again, we're going to use our factoring flowchart here, but now we're going to go on the 3-term route. So the first thing we need to do with this problem, as always, is set it equal to 0. I always want my x squared term to be positive, so I'm going to move the 14x over to the other side. So add 14x over. Now we want to make sure that we have our equation in standard form, which is what it looks like up here on the top right. So our x squared term is going to go first, then our x term, and then the term without the x. All 3 of these are not like terms, so we cannot combine any of them because they have different x's with them. So we have an x squared, an x, and then a no x term. Okay, so following our flowchart, does this polynomial have a GCF? No, it doesn't. The first term doesn't have a coefficient, it's just x squared, so there's no number to pull out, and there's not an x in every term. So no GCF. How many terms are there? There's 3 this time. What is the first term? So right now our first term is x squared. We'll get to the ax option in a minute. This is a level 1 factoring situation. Find what multiplies to c and adds to b. So c and b. Our c here is 33 and our b is 14. So we're trying to find 2 numbers that multiply to 33 and add to 14. Sometimes this is really easy. You're like, oh man, I know those terms. They're such and such. But sometimes it's hard to think of these. So I'm going to show you a way that you can write out every term or every factor of 33 so that you're sure to get your 2 numbers that you need. So we're going to start with 1. You say 1 times what is 33? Well, that's 33. And then we're going to say 2 times what, which there's nothing, that 2 multiplies 2 to give us 33. And then 3 times 11. And then you can say 4, 5, none of these multiply to 33. All the way until you get back to 11, and you know that you have all of your terms. So, either 1 and 33 or 3 and 11 are going to have to add to 14. Well, it's pretty easy to see that that would be 3 and 11. So, double check. 3 times 11 is 33, and 3 plus 11 is 14. Be sure to always check your terms at this point, especially whenever we start using negative numbers, because it's really easy to accidentally pick the wrong 2 terms. Okay? So always double check your terms. So now that we have found those numbers, we're going to write our quadratic in a factored form. So we're going to put an x in each of these spots, and we're going to put the terms or the factors that we just found in the open spots here. Doesn't matter which one goes where. So you can put plus 3 in the first one, or you could have put them the other way. Doesn't matter. Okay? So once you have that, if the directions say to factor, then we would just stop. We would be done with the problem. But if they say solve, which we're going to do today, we're going to set each of the parentheses equal to 0 and solve. So we get x equals negative 11 and x equals negative 3. Okay, on our next problem, again we need to make sure that this is set equal to 0. So add over the 15x and write our quadratic in standard form. So the x squared term first, the x second, and then the non-x last. Okay, let's check out our factoring flowchart. First of all, does the polynomial have a GCF? Well, I see 5, 15, and 10, so it does have a GCF this time. I'm going to pull out my common factor of 5. So divide each of these terms by 5. We get x squared plus 3x plus 2. Continuing on down our factoring flowchart, how many terms are there? Oops, I went this way. How many terms are there? There's 3. What's the first term? So looking in the parentheses, because that's what we're about to factor, our first term here is x squared. Okay, at first it started as 5x squared, but pulling that GCF out, kept us having a level 1 factoring problem. Okay, so now we're going to figure out what multiplies to our C term and what adds to our B term. So 2, writing out all the factors of 2, it's a pretty long list here. 1 times 2, and that's about it. 1 and 2 multiply to 2 and they add to 3. So we have x plus 1 and x plus 2. If the problem said to factor and stop there, we would just be stopping here with this answer. But we're going to go ahead and solve it. So set each of these parentheses equal to 0 and solve. Okay, now we're going to talk about factoring by grouping. That's when we have a number out front of x squared that doesn't get pulled out as a GCF. So step 1 is to find two numbers that multiply to AC and add to B. So we're going to have to actually multiply together A and C this time and see what two numbers multiply to those and add to B. Next, we're going to rewrite the BX term using the factors that we just found. Step 3, we're going to group the first two and the last two terms and pull out their GCFs. Step 4, we're going to rewrite the expression in parentheses. And step 5, if the directions say solve, we're going to set each of the parentheses equal to 0 and solve. Okay, so factoring flowchart, starting off, does this polynomial have a GCF? No, it does not. Our coefficients on here are 2, -1, and -6, and nothing is going to divide out of all three of those except for 1. So no GCF. How many terms are there? There's 3. What's the first term? Well, this first term, we're now over here to the ax squared because there's a number in front of the x squared. So this is a level 2 factoring situation, and we're going to factor by grouping. So we're going to figure out what multiplies to a times c. A times c, 2 times -6 is -12. So we want to know what multiplies to -12 and adds to -1. So let's come over here. I'm going to write out my factors of 12. Notice I'm leaving the negative off right now. We'll get to that in a minute. So factors of 12. 1 times 12, 2 times 6, 3 times 4, and we're back to 4. Okay, so we need to see which of these could add to a -1. We can put negatives wherever we want, and we need to see which add to a -1. So I could check out, let's see, -1 and 12. No, that would add to 11. No way that those are going to add to a -1. 2 and 6, they can't add to a -1. But 3 and 4, those are 1 away. If I make the 4 negative, those will add to a -1. -4 plus 3. And they will multiply to -12 like I want as well. So make sure you're always double checking that your factors give you what you want. So what we're going to do is we're going to rewrite this middle term using -4 and 3. So here we go, 2x squared. It does not matter if I use -4 first or 3. I'm going to put -4x plus 3x minus 6 equals 0. Okay, so let's stop and talk about that. These two terms right here add to a -1x. That's what I just replaced. So I didn't change the problem, I just rewrote -1x as -4x plus 3x, and you'll see why in a minute. Again, it doesn't matter. I could have put my I could have put my 3x term here and my -4x term here. Doesn't matter, we would get the same answer in the end. So we're now going to we're going to group these together. So take the first two terms and then the second two terms. Looking at just the first two, we need to pull out a GCF. Between 2 and 4, we can pull out a 2. And I have an x in both terms, so I can also pull an x out. What I did to get x minus 2 is I divided each of these by 2x. and I was left with an x for the first term and then a minus 2 for the second term. Likewise, in my second parenthesis here, we're going to pull out a GCF. In this case, is just 3. So divide 3x by 3, we get x. Divide negative 6 by 3, we get negative 2. Notice now that I have something going on here in my parentheses, that these two are the same. At this step of the problem, those always have to be the same. If they are not, you did something wrong further up in the problem. So always double check, make sure that those are the same. Now the way that we write this again is we're going to write this once. Then we're going to take what we pulled out front here, and we're going to put those in their own parenthesis together. So we get 2x plus 3. Now if the problem said factor, we would stop here. We're going to go ahead and solve it. So set each of these equal to 0 and solve. Okay, I know that might have been a lot coming at you. We'll do some more examples though. Okay, next problem. Looking at our factoring flowchart, first thing is, do we have a GCF? Nothing divides 5, 18, and 9, so no GCF. How many terms are there? There's 3. What's the first term? Again, we have an ax squared term because we have a 5 out front. This is a level 3 a level 2 factoring, and we're going to factor by grouping. So here we go. Figure out what multiplies to a times c and adds, so we want multiplies to 45 and adds to negative 18. I'm going to write out my factors of 45. I have 1 and 45, 2 and nothing, 3 and 15, 4 and nothing, 5 and 9, 6 and nothing, 7 and nothing, 8 and nothing, and we're back to 9. Okay, so looking at my 3 different terms here, the only ones that could add to negative 18, and remember I can put negatives wherever I want to, would be 13 and 15. In order for those to add to negative 18, they both have to be negative. So let's check them down here. Negative 3 minus 15 is negative 18. And negative 3 times negative 15 is positive 45. So we're good. Okay, so rewrite our middle term here using negative 3x and negative 15x. So 5x squared, I'm going to put my negative 15x because I think that 15 and 5 will have a common factor. Minus 3x plus 9 equals 0. So again, those are equal, same thing, I just rewrote negative 18x in a different way. Okay, group the first two and group the second two. Make sure that you include that negative sign in your parentheses for the second two. Now I'm going to pull out a greatest common factor in the first parenthesis, which is going to be a 5x. Once I divide each of these by 5x, I'm left with x minus 3. In my second parenthesis, I can pull out a negative 3, divide each of these by negative 3, and we get x minus 3. We want to check and make sure that these are the same, which they are. And now we rewrite these. We put this in one parenthesis. And then we take our other two terms and we put them in their own parenthesis. Okay, if the problem said to factor, you would stop here, but we're going to go ahead and solve. So we get x minus 3 equals 0, which means x equals 3, and 5x minus 3 equals 0. So we get x equals 3/5. Okay, I want you to pause your video and try these two problems. For this first problem, it was level 1 factoring because we didn't have an a out in front of the x squared. So I found my factors to be 4 and -2. I checked them down here to make sure that they added to +2 and multiplied to -8. Okay, with this last one, I had to figure out what multiplied to -10, a times c, and what added to -9. So I wrote my factors of -10 out here to the left, and I found that 1 and 10 could add up to -9. I checked down here and made sure that -10 and 1 would add to -9 and multiply to -10. Okay, so I rewrote the middle term. I put -10x first and 1x second. You could have switched those, that's fine. And then I pulled out my GCF. So down here I want you to notice that I didn't really have a GCF in this one, but you always have to pull something out. So I put a 1 out front here. Okay, so you always have to pull something out on these problems, and I put a 1. That way I could have a 1 down here in this parenthesis.